a particle of mass 5 kilograms, I always like to take out the quantities. Slides from rest. U is 0. Down a smooth plane inclined at 30 degrees. Should I write theta? 30 degrees. Yeah? We are asked to find the magnitude of the normal reaction. We don't know the normal reaction. The acceleration, we don't know A. And its speed after 2 seconds. When t is 2, we are asked to find V. Okay. You read through the problem, you reason it. It is sliding down a smooth plane. The plane is very smooth and it is inclined at 30 degrees. So here is your smooth plane, inclined at 30 degrees. And there is a particle on this plane. All you do is find all the forces on the particle. We should have the weight mg. mg. So m here is 5. So the weight is 50 newtons. Then we have the normal contact force. Call it R, which is what we are looking for. We have it here. We are looking for R. What else? Is there any other force? No. We are told that the plane is smooth. Since the plane is smooth, there is only 2 forces acting, right? There is no friction. So we can resolve the weight into perpendicular direction. You will have 50 cos 30 here. And there is a parallel direction. You have 50 sine 30 here. And we are asked to look for R, the normal reaction force. So if we resolve perpendicular to the slope, we get R is equal to 50 cos 30, right? What is cosine of 30 anyway? What is cosine of 30? Can somebody tell me what is a cosine of 30 degrees? If you forgot.
The root of 3 by 2.
3 over 2, yes. If you ever forget, just go through this quickly. 30, 45. That's 0, pi over 4, pi over 3, pi over 4, pi over 0, pi over 6, pi over 4. pi over 3, which is 60 degrees, and pi over 2, 90. And then sine 0, root 0 over 2, root 1 over 2, root 2 over 2, root 3 over 2, root 4 over 2, 1. And then for cosine, the opposite side, 0, root 1 over 2, root 2 over 2, root 3 over 2, 1. So this will be root 3 over 2. So that's 25 root 3. That's the exact value. Next, we need to find the acceleration. The object is sliding down, so the acceleration is this way. And the resultant force along the slope is just this force, 50 sine 30. So we have to use Newton's second law. So we resolve parallel to the slope. We get F equal ma, right? The resultant force is 50 sine 30. It is equal to the mass, which is 5 times A. That gives you A equal 50 sine 30. Sine 30 is 1/2. 50 sine 30 over 5. So that will give you 25 over 5, which is 5 meters per second squared. And then, when that is done, the last thing we need to look for is the final velocity after 2 seconds. So now we have to use our Suvat equations. U is 0, U is 0, A is 5, T is 2, and we are looking for V. Which equation should we use here? Which equation? Ruby, which equation should we use here? Ruby?
Yes.
Which equation should we use in this case?
V equal to U
V equal
plus
U
AT.
plus AT. Perfect. So V should be 0 plus 5 times 2. So it will reach a velocity of 10 meters per second. So this is an example of how problems like this should be solved. I'm sure those of you guys who already solved all the problems, that's a lot of hard work you are doing. And it's very nice, it's very good to do that. But always remember to keep your work clean, okay? When I checked your work yesterday, one little problem I see most of you guys have is this diagram of forces. Remember to draw your forces carefully. The diagram is not too important, it's a sketch. But these forces, it's a good idea that you should make these forces, like this mg should actually look vertically down. It should not be tilted to some angle. And make it big so that we can see clearly those forces. So that is the only little problem most of you guys, I see some of you guys have, not everyone, but some. Okay, let's look at another problem. For those who did not do this work yet, let's look at question 3 and see. Question 3. Okay, it says a box of mass 10 kilograms is pulled along a horizontal surface by a rope with tension 20 newtons at an angle theta above the horizontal. Horizontal surface. And there's a box of mass 10 kilograms. Once we hear mass is 10 kilograms, we think of the weight. The weight is 100 newtons. You can call it mg equal 100 newtons. And then there's a normal reaction force. Call it R. And we are told that it is pulled with a force that has tension of 20 newtons. So it is pulled like that. 20 newtons. This is strange since here my 100 newtons is actually shorter than my 20 newtons. So I'll need to do something on my 100 newtons here. I need to make it much larger. 100 newtons. And we are told that this angle here is theta. And we know the acceleration of the box is A is 1.2. We are asked to find theta and the normal contact force. So what do we do here? We can resolve this 20 Newton force into a horizontal component, 20 cos theta, and a vertical component, 20 sine theta. And now we can resolve our forces horizontally. We will get F equal ma horizontally. The resultant force horizontally is 20 cos theta. So 20 cos theta is equal to, mass is 10 times acceleration is 1.2, right? So from there we can find cos theta. Cos theta is 12 over 20, whatever that will be. What is 12 over 20? That should be 3 over 4, right? 3 over 5, correct? So that means that sine theta will be 4 over 5. Sine theta is 4 over 5. So we can now resolve vertically. We apply Newton's second law vertically. There is no acceleration vertically, so it is just the sum of forces should be 0. So this force should be equal to that force. So we'll get R plus 20 sine theta should be equal to 100, right? And so that gives us R equal 100 minus 20 sine theta. And we know sine theta is 4 over 5. So we can just put 4 over 5 here. So that will be 100 minus 20 times 4 over 5, which we can solve. Okay. We have like 6 minutes left. I think at this point, I should leave you guys so that those who have not solved the problems, you should go ahead and solve them, okay? Use this time to solve them. And those who have further math, you should also be working on your further math as well. For the further math today, I just need you to solve these 3 questions on page 545. That's all. Solve and submit on Edmodo. Okay? Okay. Thank you all for coming, and see you. Bye.
Bye.
Bye.